Write down the gradient of a line perpendicular to AB. Okay, so basically M1, gradient for the first line, we'll call it M1, the gradient for line 1. We said that was negative 10 over 9. And then the gradient of line 2, we'll call it M2. And it's just a simple thing. Again, we unpack this in class in terms of rotating, and perpendicular means 90 degrees. So automatically for any line, we flip the gradient, the rational number for the gradient, and we change the sign. So that's the gradient, it's 9/10. So it's the 9/10 times table. For every 1 unit along the x-axis, the line rises by 9/10. Okay, so it's just a bit less than 1, 0.9. Okay, so now over here, calculate the equation of a perpendicular bisector. Well, perpendicular means 90 degrees. So the first line looks like this. The second line looks like this. It's 90 degrees here. So we've already got the gradient of the first line, is negative 10/9. We've now got the gradient of line 2, which is 9/10. So 9/10, that bit of information comes from this word. And now bisector. Okay, so bisector means split into 2 pieces, exactly the same size. So the bisector of AB goes through M. So this point here is point M. So here what we're trying to say is, what is the equation of the line y equals mx plus c? We know that m, the gradient, is equal to 9/10. And we know it goes through the particular point M. So it goes through 7 over 2, comma 1. All right. So this calls for a little bit of algebra, but not too much, because now we go y equals 9/10, the gradient, x plus c. So we need to find out what is the plus c. Now you can go back to the diagram and try and draw on the line, which I'll try and draw now in green. Let's get this guy here. So I can do it kind of roughly and have a best guess. Okay. And now we have the same problem as before. You know, we're trying to find, well, what is this value here? Because that would be the plus c for y equals mx plus c. But it looks like it doesn't go through a nice whole square, so we can't really read it off. We have to have another way. And it's just the same way we did the previous one, that the value of the plus c, the y-intercept, has to make this equation balance for all the values that are on it. And notice that when x equals negative 7 over 2, y equals 1. So this pair of values has to work for this equation. So we go ahead and substitute them in, and then we find the c that makes this equation balance. So the y value is 1. That has to match to 9/10 times the x value plus c. Okay, let's just have a look. Let's see if we can change the width of my pen. There we go. Okay, so when we crunch this out, we've got 1 equals to negative, 9763 over 20 plus c. c is equal to 1 plus 63 over 20. And then if you do a little bit of fraction work, change this guy to 20ths, you should get 20 plus 63 is 83 over 20. Wow. So your final equation, I'll put it in a box, y equals to 9/10 x plus 83 over 20. Okay, and we won't play around with that anymore, we'll just leave it like that. And now let's have a little look. Yeah, because look, 83 over 20 is about 4, just over 4. And when you zoom in here, you can see it's just above a height of 4. All right. So now we write equation of L1 in general form. And so let's write down equation 1. Y equals to negative, oh there you go, negative 10 over 9x minus 26 over 9. I'll write down L2 down here as well. Y equals 9/10 x plus 83 over 20. Now the end goal is we're trying to get it in the form ax plus by equals d, and a, b and d are nice whole numbers, integers. Now the reason, I've explained in the video, the mathematicians like to have things, especially algebra, in different forms. So this is gradient intercept form, and this is general form, and these are the equations of straight lines. And each particular form kind of has certain benefits and disadvantages. And again, I've unpacked that in another video. You'll be able to watch that. And we can discuss in class as well. So the easiest way of getting rid of any fractions, because remember, the a, the b, the d have to be whole numbers, kind of fractions. The simple way is times both sides by 9. Okay, so you times everything by 9. To keep the equation balanced, this is 9y here, this is negative 10x here, this is negative 26. And then rearrange. So if you add 10x to both sides, you'll get 10x plus 9y equals to negative 26. And you have indeed done exactly what you need to do. You've rearranged the equation into general form. Okay, this last part is a little bit trickier. I have a 10 as a denominator. Oh, let me just undo that. Highlighter on. I have a 10 as a... Oh, I'm not doing very well for this last question. There's the highlighter. You have a 10 as a denominator and a 20. You could times both sides by 10. And that'd be a good start, but the better number to multiply both sides is 20, because 20 is the lowest common denominator of 10 and 20. So that's a trick that will speed up some of your rearranging. So I'm going to times both sides by 20. So left hand side becomes 20y, the right hand side becomes 9 times x times 20 divided by 10. And then this guy becomes 83 times 20 divided by 20. So I've done that for you just to show you, what happens. And can you see that actually the times 20 divided by 20 simplifies to 1. And here the times 20 divided by 10 simplifies to a times by 2. So 20 over 10 becomes 2 over 1. So now you can finish off the equation. And this final one is 20y equals 9 times x times 2, 18x, and then plus 83. And then we do a final rearranging, and that's 20y minus 18x equals to 83. Subtract 18x from both sides. And then to get it in exactly the right format, the ax plus by equals d, we just simply put the negative 18x first, then plus the 20y equals to 83, and that is our final answer just there. Alright, so I hope that helps.